welcome back you guys to Igcse Math Solution. Today our topic as you know is recurring decimals to fractions. So first let's just get a hang about what the notation is. How do you identify recurring decimals? So there are two methods basically. First one is the dot notation wherein you use a single dot or two dots to represent the recurring decimals, and the other one is a dash notation. So let's just take an example. Suppose I have a number which is 0.333 recurring. So in this dot notation, I'll be writing it as 0 0.3 and a dot on top of the 3. This dot. So this dot will represent that 3 is recurring. The number 3 digit is being repeated. In dash notation, it's quite similar. All they do is replace this dot with a dash. So let's take another example to get a hang of it. Now, in this first case, we had only a single digit which was repeating. If we have two digits repeating, which means 0.121212, this is repeating. So in the dot notation, it will be right 0.12 and there will be a dot on 1 and the second dot is on 2. Now what do these two dots mean? This first one means that the recurring portion starts from the first dot. So from this first dot, the recurring portion starts, and on the second dot, it ends. So the first dot tells us that there will be two digits in this recurring portion, and the recurring portion is actually 1 2. Similarly, if we have the dash notation, so in dash notation we'll write it as 0.12 bar. So there will be a bar on 1 2. In the dot notation, we have a starting dot and an ending dot to represent the portion which is being repeated. In bar notation, we put a bar on all the digits which are being repeated. Just one final example so that you are thorough with what we just learned. Let it be 0.134, 134, and so on. So in the dot notation, we'll write it as 0.134. Then the first dot will come on 1 and the second dot will be on the 4, because we know that the repeating part is 134. So it starts from 1 and goes on till 4. Next, coming on to the bar notation, we'll have 0.134 bar. So it's quite simple. So now we have to convert recurring decimals to fractions. If we see recurring decimal, whatever you multiply with it, all the parts, and it goes on till infinity. So what we need to do is we have a few steps to solve it. First step is assume. Assume my recurring decimal to be equal to x. So first we'll assume that the given decimal to us, that number is actually x, and next what we will do is we'll multiply it by powers of 10. So when third, we'll take two equations, then we multiply it by some power of 10. First we have an equation which we have assumed, the first equation, and then we have a second equation over here which will be when we multiply it by some power of 10, and finally we'll subtract. Don't worry if you're losing track. When I take an example, it will be a lot clearer. So let's straight away get to an example. A simple example would be 0.222. So firstly, we'll write it in the two notations we just learned. You can write it as 0.2 and a point, or it will be 0.2 bar. Next, my first step, step 1. Step 1 was nothing but assume. So I'll assume 0.2222 this to be equal to x. Now I can multiply it by any power of 10, but let me just try and multiply it by 10. So I'll multiply 10 on both the sides. On the LHS, I get 2.222 recurring again. that will be equal to 10x. Now, this was my second step. Now, for the third step, we had mentioned we'll subtract. Now, if I closely look that if I subtract the second equation from the first one, I can see that my decimals, they are equal. So because we had actually shifted the decimal place, and after the decimal we have infinite number of tools, so we can almost assume that the number of tools after the decimal place are same in both the equations. Now when I subtract equation 2 from equation 1, what do I get? I get 2.222, the recurring part, minus 0.222, the recurring part, that is equal to 10x minus x. So this recurring decimals get cancelled by these recurring decimals. So it is effectively just 2 minus 0, because this part and this part gets cancelled. I have only this 0 in front and the 2 which remains, and that will be equal to 9x. So 2 is equal to 9x. Now I can divide it by 9. I get x as 2 by 9. So this is actually the fraction. So I've converted this 0.222, 0.222, that the recurring decimal is nothing but 2 by 9. So you see, it is so simple, but now we'll take another example. Example number 2, and this time we'll take something a little bit more complicated. You can assume 0.234 bar. So 0.234 bar, this is the number. Firstly, we'll convert it to the dot point. Firstly, we'll just convert and see what we get in the dot notation. So you can write it as 0.234. First dot is on 2 and last one is on 4. So this was just for practice. So if you want, you can pause the video right now and try to find the answer on your own and comment the answer down below. I'll be giving the solution right away, but it will be great if you try it yourself. See, whatever you learned in this video till now, using that concept, you can easily find the answer to this. So pause the video right now, give it a try, use some pen and paper, and try to solve it yourself. Because when you do that, you give your brain a practice. So just try it out right now. And now for the solution, remember the three steps. First step, assume. So I assume 0.234 bar to be equal to x. Now next I have to multiply it by some power of 10. So if I multiply it by 10 itself, what will I get? I'll get 2.34, and then I have these repeating. It will be 234, 234. So I'll have a bar over here. So this is equal to 10x. But if you see now, my decimal is not exactly same. Let me try 100 times. So when I multiply this first equation by 100, I get 23.4, and then I have 234 which is repeating. This is 100. Still, if you notice, there is nothing exactly same in the first equation and my third equation. So this was also a failure. Let's try 1000 times. So this is my fourth equation. When I multiply 1000 times, I get 234.234 bar. Yes, this is something useful. You see, because now in the first equation, here and over here, I have the same decimal places, exactly same decimal places. So now I can use the third step, which was to subtract. So I'll subtract 4 from 1. So what I get is 234.234 bar minus 0.234 bar. That will be equal to 1000x minus x. So once again, my decimal places are same. So what I can do, you can see that straight away cancels out. So these decimals and this decimal cancels out one another. So finally what I have left with me is 234, which is equal to 999x. Now my x is nothing but 234 by 999. So we need to check our answers, that is for sure. So let me just open the calculator once. So what we got was 234 by 999. Let's just see. So if you notice, it is nothing but 0.234234. Here the 234 is getting repeated, which is exactly what we had thought. So that's it, guys. Today I think I have imparted some knowledge to you, passed on this recurring decimals to fractions. It is an extremely easy topic, just that you have seen. All you need to figure out is what power of 10 you should multiply. And for a pro tip, one thing if you would have noted, I'm sure that the number of places in the decimal which is getting repeated, like in this example of 0.234 repeating, here we had three places which were repeating. So we have to multiply by 10 raised to 3. So, but don't take this as a rule. You might have something different, as in if you had 0.12, and but this is not the repeating part. The repeating starts after this. So after this you have 3, 4, and the 3, 4 is only repeating. So this would look something like 0.12, 3, 4, 3, 4. So in this case, you cannot, if you see that I have only two decimals repeating, I will multiply by 10 raised to 2, which is 100, but that will be wrong. So normally, what you do is you multiply by the number of digits that you have in the power. If not, you want to remember something as a rule, you can remember that the number of decimal places, like the recurring part starts from the third place and you have two places before that. So what you can do is you can try to multiply it by 10 raised to 4 in this case, so that you remove this 1 2 and you have this 3 4 also removed, and then after that the decimal places will have only the repeating part. So the pro tip is just you can remember something, that the number of digits which are getting repeated, you can multiply by that power of 10 and try. If not, try something else. I'm sure you'll definitely get to it. And once you get the knack of it, it will be extremely easy to convert any recurring decimals to to the fractions, and you'll no longer need a calculator for that. So that's it, guys, for this video. And do remember to subscribe to my channel, like it or dislike it if you did not like it, so that I can create better and better videos for you all. Share it with others, share it with your friends, your family. If nothing, it's just something very simple. You can impart knowledge to someone else as well. Do remember to follow me on Instagram, Twitter, and Facebook. The links are down in the description box. And yes, in the end, just subscribe, and thank you for watching.